So here's an introduction to regression analysis. In this first, what I'm going to call core of the class, or first topic of the class, the topic is simple linear regression. This is where we would take one variable and try to use it to predict a second variable. That's really all regression is, taking the knowledge of one variable and trying to predict a second variable. So it could be knowing what the price of gas is and trying to predict the demand for gas. My first project was looking at the demand for ice cream. What impacts the per capita demand for ice cream? And I don't know about all of you, I certainly like ice cream. On average in the U.S., we each eat about 19 pounds of ice cream a year. Now I know many of you don't, because I probably consume about 30 to 35 pounds of ice cream a year, so I bring the average up, so those of you don't have to eat quite as much of it during the summer months. But that's what we're doing. We're trying to predict one variable given our knowledge of another. The variable we're trying to predict or explain or understand is called the dependent variable, and sometimes you'll hear me call it the DV, so I just use the acronym DV for the dependent variable. This is a variable that's being impacted, estimated, tried to understand. So this is the number of cars that are sold in a month, or the pounds of ice cream, or the per capita demand for chicken in the world, or the price of, we're going to be using a lot in class, trying to predict the asking price of a home given a characteristic of that house. The variable that we're using as a predictor, trying to predict the variable with, is called the independent variable. So that's that's how many dollars in advertising we spent on impacting sales. That's how large the house is on the asking price of the house. That's the price of a ice cream cone and the demand for that ice cream. So simple linear regression, one independent variable, one IV, and we're trying to use that to predict, explain, or understand a second variable called the dependent variable, the DV, and that's usually what we do. So under the resources tab in OnCourse, you should be able to pull up a data set. These are some home listings from the Prudential Columbus website on December 24th, 2012. And you can see we've got the asking price of a house, the number of bedrooms, the number of bathrooms, the square feet in the home, whether or not there's acreage or not. And I believe, if I remember correctly, acreage was coded 0 if there was less than a half acre along with the home, and a 1 if there was a half acre or more. Then the age of the home and its location. 0 if it is in Columbus, 1 if it's in Carmel. So we'll look at those 0, 1 variables. Those are called dummy variables. We'll get to that in multiple regression, but that's the data set that we have. And so that's the one we'll be working with about the first half of the class. Now, one other thing to look at is, what is the relationship between correlation and regression? Regression attempts to describe the nature of the relationship between a independent variable and a dependent variable, usually using some kind of mathematical terminology. And it's looking at the magnitude, how strong, or what is the impact of that independent variable on the prediction of that dependent variable. Correlation doesn't look at magnitude. Correlation just looks at the strength of association between two variables, not necessarily what they are. For example, one of the craziest correlations I've known about is that the sidewalk temperature in Madison, Wisconsin is highly correlated with the birth rate in Norway. Now, obviously there's no causal relationship there. You can't warm or cool down the sidewalk in Madison, Wisconsin, and expect that the birth rate in Norway is going to go up or down based on what you've done to the sidewalk in Madison. But they're highly correlated. And unfortunately, most of the research that you see on television and the media is correlational in nature, not causal. And if there's one thing I hope that you'll understand in this class, and it's one thing my poor wife has found out through 26 years of marriage is that correlation does not imply causality. She's even picked that up from this crazy old kook who teaches statistics that she's been married to for so long. So just remember that right now is, again, correlation looks at the strength of the relationship. Regression looks at the magnitude and tries to describe the nature of the relationship.